Is it on?
Yeah.
Hi, my name is Matt Dorigo.
Hi, I'm Catherine Tupper. Okay.
Okay. So basically, for problem one,
So
there's a springy ball that is dropped, and then it compresses and is bounced back up. And the initial velocity is speed hits the table, and then at the moment of impact, kinetic energy is equal to 1/2 mass times the velocity, initial velocity squared, and potential energy is 0 because it's on the table. It no longer has potential energy. However, it's springy, so it springs back up. Just after impact, kinetic energy equals 1/2 mass times velocity final squared, and VF is slightly less than VI. Change in kinetic energy is equal to 1/2 mass times velocity initial squared minus 1/2 the mass times the final velocity squared, which is equal to 1/2 mass times VI squared minus VF squared. So the table gains energy equivalent to the change in kinetic energy.
and then the ball jumps back up because it is springy, and the kinetic energy of the compressing when it hits the table causes it to shoot back up. Pi equals m initial velocity, p final equals 0, delta p 0 minus mass times initial velocity equals negative m vi, which means the table has to gain that much momentum. Back to Matt.
Okay. So, it's a closed system, and initial momentum has a force vector going up. Delta t is the change in momentum. Final momentum is the force times delta t. The non-bouncing ball also has a force vector, and then the change in momentum is 1/2 that of the bouncing balls, and the final momentum is 1/2 that of bouncing balls. This is the non-bouncing ball I was talking about. It is also a closed system for kinetic energy. The bouncing ball's initial kinetic energy is 1/2 the mass times velocity initial squared. The change in kinetic energy is 0, and the kinetic energy final is 1/2 mass times VI squared. The non-bouncing ball is one that doesn't bounce back up. Is initial kinetic energy of 1/2 mass times velocity initial squared minus 1/2 mass times velocity initial, the negative 1/2 mass times velocity initial squared. Kinetic energy final is 0 for the non-bouncing ball. And the for the other closed system is this previous, basically.
Okay.
So, that is problem
Number 1. So here is problem number 2 about it's on the bottom. Okay. So
And
here
by the way, the one that on problem 1, the bouncy ball shot back up because it was compressed, and then it shot back up, and the non-bouncing ball wasn't compressed. It didn't have springy capabilities, so it
Yeah.
just sat there. Anyways, problem 2.
So here
A bowling ball and a billiard ball roll toward a wall at the same speed. They both hit the wall head on. One has a much greater mass, though. What one will make a bigger dent in the wall? So basically,
we have our bowling ball and our billiard ball.
the bowling ball has a way bigger mass, and the billiard ball has a way smaller mass, which I represented by big M and little m. The initial momentum is the big mass times velocity initial. Final momentum is 0. The change in momentum is the negative mvi. Impulse is equal to negative mvi over delta t, but because it has a bigger mass, it has a greater impulse, whereas when you have the initial momentum of the billiard ball, it is represented by the small m, meaning a smaller mass. We don't know the number. Mass times velocity initial, final velocity is 0. The change in momentum is negative mvi. Same as up above. Impulse is negative mvi over delta t, same as above. However, it has a smaller m, smaller mass, meaning it has a smaller impulse and will make a smaller dent in the wall.
So the impulse created by the bowling ball is greater than the impulse created by the billiard ball due to the bowling ball's bigger mass. And that is that it?
Yeah, I would say
Okay,
that's pretty
So
cool.
here's number 1, number 2, and we're done.